Alright, so let's talk about run some query 2D immutable. So given a metric, 2D metric, so you just have to calculate the sum of the element metric inside a rectangle defined by its upper left corner and lower right corner. So this is like you have to define in the metric, and this is from upper left to lower right. So 2, 1 and 4, 3, right? So just calculate the sum of it. So this will become 2 plus 1 plus 1 plus 1 plus 3. And I think this is become 4, 5, 8, right? 8. And there's another rectangle 1, 1, 2, 2. So 1, 1, 2, 2. And this will become 11. Yes, correct. So by using the previous method, so if you look at the questions 303, and you will be able to know we use the previous sum technique. So I calculate for every single element, and then I mean the sum of the element for every single cells, and then I will just using my 2D array to calculate what is the little bracket solution. And if you look at the solution tab, this is pretty much it. So I'm using this technique. So if you want to calculate the ABCD rectangle, you grab everything from OD and subtract OB, subtract OC. And since you subtract twice on OA, right, you need to plus OA. And this will become the best solution. And if you're using some range, right, this will take you all of 1 because you already traversed all of, m times n, right, or n squared, doesn't matter. So this will actually give you the best performance. So let's just start coding, and if you have any question, you can ask later. So in 2D, right, PrevSum. So I'm going to say in m equal to metric.length, and also n equal to metric at first position. And I'm going to traverse. So before I traverse, I need to initialize that. So PrevSum equal to new int m plus 1. Don't forget you need extra space for this. The reason why you need extra space is because you need to basically you don't need the first row and the first column. You just have to collect every sum from these cells to these cells, and then this will actually determine the previous sum. So for this cell, right, you add a top left and top left, and then this will actually become your first cells on previous sum. So for int I equal to 1, I less than m, less than equal to m, I plus plus. So in j equal to 1, j less than equal to n, j plus plus. So previous sum is actually ai and j is equal to metric. So this metric. So if you want to calculate 1, 1, right, we need to get this value. 3, 3, right? 3. So I minus 1, j minus 1, and then plus the top and the left, right? Plus previous sum I minus 1, j plus PrevSum I, and then j minus 1. But we also need to subtract the PrevSum I minus 1 and j minus 1. This is because when you take everything, imagine that when you take everything from here, and then you need to calculate for this position, right? You still need everything from here, right? So you need to subtract this value, and when you subtract this value, you will actually get this. The rest of the cells sum, and then this will become more accurate. So PrevSum minus PrevSum at I. Let me just move a little bit. At I minus 1 and j minus 1. And here we go. So when you want to return for the sum range, right, you will be able to know that you take everything from OD, right, from O to D, everything, right. So when you're using a PrevSum, you have extra space, and then just making sure if you take everything from OD, and then you have to have +1 on the row and the column. So PrevSum row 2 + 1, column 2 + 1. Subtract. So subtract OB. OB, you don't need the +1 on the row because you are not including B, right? So PrevSum row 1 and then column 2 + 1. Subtract OC. The OC is PrevSum. And if you know it's row 2 + 1, and then you don't need to include it in the column. And you need to add OA, right? So PrevSum row 1, column 1. And this will become your solution. So let's just run it. Hope I don't have any typo. Alright, here we go. So let's just run it. And this is the solution. So let's talk about time and space complexity. So this will give you all of m times n, right? M times n. So time is all of m times n, and which is all of m n. And then for the sum range is all of 1. And this is the best solution ever. And if you want to have all of n-squared solution, you can just traverse using the for loop. But I'm not suggesting you do this. And if you have any question, leave a comment below, subscribe if you like it, and give anything feedback if you want. Alright, bye.